Welcome to this comprehensive overview of general math. In this presentation, we'll explore fundamental mathematical concepts critical to technical and vocational fields, from number systems and arithmetic operations to geometry, trigonometry, and measurement. Let's begin. Mathematics begins with number systems, the foundational way we represent and work with quantities. The three major numbering systems we'll cover are decimal, binary, and Roman numerals. The decimal system is a base 10 system, using digits from 0 through 9. By reusing these digits in increasing place values, ones, tens, hundreds, and so on, we can represent an infinite range of numbers. Negative values are indicated using a minus sign, and fractional values are denoted with a decimal point. Binary is a base 2 number system, using only 0 and 1. It's essential in electronics and computing due to its simplicity and compatibility with electrical on-off states. Each digit, or bit, represents a power of 2. Think of binary as a sequence of switches, on or off, where each switch represents double the value of the one before it. A switch in the on position equals 1 and off equals 0. For example, 2 switches in the on position equal 3. This is a table showing the binary and decimal numbers equivalent. Whole numbers are the fundamental building blocks of arithmetic. They include all non-fractional numbers, starting from 0 and extending infinitely in the positive direction. These numbers are manipulated using 4 basic operations: addition, subtraction, multiplication, and division. Addition is the process of combining 2 or more quantities to find their total. The result of this operation is called the sum. Subtraction involves finding the difference between 2 numbers. The number from which another is subtracted is called the minuend. The number being subtracted is the subtrahend, and the result is the remainder. Multiplication is a method of scaling one number by another. It simplifies the process of repeated addition. The number being multiplied is the multiplicand, and the number doing the multiplying is the multiplier. Division determines how many times one number is contained within another. The number being divided is the dividend, the number dividing it is the divisor, and the result is the quotient. Fractions represent parts of a whole. They exist between whole numbers and are categorized into 3 main types: decimal fractions, common fractions, and mixed numbers. Decimal fractions are based on powers of 10. A decimal point separates the whole number from the fractional part. For example, 0.1 is 1/10, 0.01 is 1/100th, and so on. To add decimal numbers, align them by the decimal point and add as usual. Proper alignment ensures accuracy. When adding decimal numbers, always begin by aligning the decimal points vertically. This ensures that each place value, tenths, hundredths, thousandths, is correctly lined up for accurate addition. In this example, we are adding 12.635 and 102.2. To make the addition easier, consider writing 102.2 as 102.200 to match the number of decimal places. Then, add the numbers as you would in whole number addition, starting from the rightmost digit. The result is 114.835. Subtraction of decimal fractions follows the same principle. Align the decimal points, then subtract as you would whole numbers. When multiplying decimals, ignore the decimal points initially. Multiply as you would whole numbers, then count and place the decimal in the final result according to the total number of decimal places in both numbers. To divide decimals, if the divisor is not a whole number, shift the decimal point in both the divisor and dividend to the right until the divisor becomes a whole number. Then, proceed with division. The decimal and the quotient should align appropriately with the dividend. Scientific notation is a method of expressing very large or very small numbers efficiently. It helps reduce errors in calculations and simplifies complex numerical expressions. Scientific notation consists of a coefficient, which is a real number, a base of 10, and an exponent, which shows how many times the coefficient is multiplied or divided by 10. Numbers are normalized by adjusting the coefficient to fall between 1 and 10. This table illustrates how powers of 10 are used to express large and small quantities efficiently through exponential notation. Positive exponents represent whole number multiples, while negative exponents represent fractions or decimal values, making them essential for scientific calculations like the speed of light or the mass of an electron. Moving the decimal point to the left divides the number by 10. To the right, it multiplies the number by 10. This adjustment enables normalization. To multiply, multiply the coefficients and add the exponents. For division, divide the coefficients and subtract the exponents. Common fractions represent a division of a whole into equal parts. The numerator indicates how many parts are being considered, while the denominator shows the total number of parts making up the whole. There are three types of fractions: proper fractions, where the numerator is less than the denominator; improper fractions, where the numerator is greater; and mixed numbers, which combine a whole number with a proper fraction. To add or subtract fractions, we first find the least common denominator. Then, adjust each fraction accordingly before performing the operation. To add common fractions, after aligning to a common denominator, add the numerators. Then reduce the result to its lowest terms for simplicity. To subtract common fractions, after aligning to a common denominator, subtract the numerators. Then reduce the result to its lowest terms for simplicity. A mixed number combines a whole number and a fraction. To perform arithmetic, we first convert it to an improper fraction. To convert a mixed number, multiply the whole number by the denominator, add the numerator, and place the result over the original denominator. To reverse the process, divide the numerator by the denominator. To simplify fractions, find the greatest common factor shared by the numerator and denominator. Divide both terms by this factor to express the fraction in its lowest terms. To multiply fractions, simply multiply the numerators together and the denominators together. Then, reduce the resulting fraction to its lowest terms. Cancellation is a technique used to simplify before multiplying. By dividing out common factors in the numerator and denominator, we make calculations quicker and more manageable, especially in algebraic expressions. To divide one fraction by another, invert the divisor, that is, flip the numerator and denominator, then multiply. Always remember, invert the second fraction, not the first. Finally, reduce to the lowest terms. To convert a common fraction to a decimal, divide the numerator by the denominator. To convert a decimal to a fraction, express the decimal as a numerator over a power of 10, then simplify. When rounding decimals, identify the digit to retain. If the next digit is 5 or greater, increase the last retained digit by 1. Otherwise, leave it unchanged. Signed numbers have a directional value from 0, positive or negative. Positive numbers lie to the right of 0, while negative numbers lie to the left. When adding signed numbers, if both numbers are positive, add normally. If both are negative, add and retain the negative sign. If one is positive and the other negative, subtract the smaller from the larger and use the sign of the larger number. To subtract signed numbers, if both are positive, subtract as usual. If both are negative, compare their magnitudes. The result takes the sign of the number with the greater absolute value. If one number is negative, change subtraction to addition and reverse the sign of the subtrahend. Multiply signed numbers normally and apply these sign rules. Positive times positive gives a positive result. Negative times negative also gives a positive result. Positive times negative gives a negative result. Just like multiplication, apply the sign rules for division. Dividing two numbers with the same sign yields a positive result. Dividing numbers with opposite signs yields a negative result. A percentage represents a value out of 100. For example, 10% is equivalent to 0.10. Percentages are widely used to express proportions, growth, and comparison. A ratio compares two quantities, showing how many times one value contains or is contained in another. It can be expressed as 4 to 1, 4 to 1, or as a fraction such as 4 over 1. A proportion states that two ratios are equal. In any proportion, the first and last terms are called the extremes, while the second and third terms are the means. If two ratios are equal, their cross products will also be equal. To solve proportions, set up related quantities in fraction form, place the known value, cross-multiply and divide to find the unknown term. Another method for solving proportions involves organizing known ratios in columns, placing known values under the correct labels, and using cross-multiplication to find the missing value. This method improves clarity and accuracy. Powers and roots extend the concept of multiplication. A power is a number multiplied by itself a certain number of times. For example, 4 cubed, or 4 to the third power, equals 64. In 4 to the power of 3, 4 is the base, 3 is the exponent, and the result, 64, is the power. Understanding these components is essential for working with exponents. A square root is a number which, when multiplied by itself, returns the original value. For example, the square root of 16 is 4. A cube root refers to a number multiplied by itself twice more. For example, the cube root of 64 is 4. These are represented using the radical sign. Area is a measurement of a two-dimensional surface and is always expressed in square units. Different shapes require different formulas, which are essential to memorize and apply accurately. The most common shapes whose areas we calculate include rectangles, squares, triangles, parallelograms, trapezoids, and circles. A rectangle has 4 sides, with opposite sides equal and all angles at 90 degrees. Its area is calculated by multiplying length by width. A square has 4 equal sides and 4 right angles. Its area is side squared, or length times width if you prefer the rectangular formula. A triangle is a 3-sided polygon with a total internal angle sum of 180 degrees. Triangles may be scalene, equilateral, or isosceles based on side lengths, and acute, obtuse, or right based on angle measures. This diagram categorizes triangles by both side length and angle type, including scalene, isosceles, and equilateral forms, each paired with right, acute, or obtuse angles. Understanding these variations is essential for solving geometric problems in structural analysis, navigation, and component alignment in aviation maintenance. Triangles are categorized based on their internal angles. A right triangle has one angle exactly equal to 90 degrees, forming a perfect L shape. An obtuse triangle contains one angle greater than 90 degrees, making it appear stretched or flattened. In contrast, an acute triangle has all 3 interior angles less than 90 degrees, giving it a sharp, narrow appearance. Understanding these angle classifications is essential for analyzing structural geometry in aviation and engineering applications. A triangle consists of 3 sides and 3 angles. Important elements include base, the side on which the triangle rests; vertex, the point where 2 sides meet; altitude, a perpendicular line from the base to the opposite angle, also referred to as the height; Hypotenuse. In a right triangle, it's the longest side, opposite the right angle. This triangle illustrates a base measuring 3 feet 2 inches and an altitude of 2 feet 6 inches. The altitude represents the perpendicular distance from the base to the opposite vertex. These two measurements are essential for calculating the area of the triangle using the formula 1/2 the base times the height. Understanding how to extract and apply these dimensions is critical for structural layout, load distribution, and blueprint interpretation in aircraft maintenance. To find the area of a triangle, use the formula 1/2 times the base times the height, that is, area equals 1/2 A times B. A parallelogram is a four-sided figure with opposite sides that are equal and parallel. Unlike a rectangle, its corner angles are not 90 degrees. Its area is calculated by multiplying the base by the altitude. To find the area of a parallelogram, multiply the base length, labeled as L, by the perpendicular height, labeled as W. This is expressed by the formula area equals L times W. This calculation is essential in structural layout and sheet metal fabrication, where accurate material dimensions are critical. A trapezoid has 2 parallel sides and 2 non-parallel sides. To find the area of a trapezoid, add the lengths of the 2 bases, divide by 2, and multiply by the height. The formula is area equals 1/2 the sum of the bases times the height. This figure is a trapezoid with a top base of 10 inches, a bottom base of 14 inches, and a height of 6 inches. To calculate the area, apply the trapezoid formula, 1/2 the height multiplied by the sum of the 2 bases. That gives us 1/2 times 6 times 10 plus 14, which equals 72 square inches. This formula is essential for determining surface areas in structural layouts and material planning in aircraft maintenance. A circle is defined by its center point and radius, the distance from the center to any point on the edge. The diameter spans the circle through the center and equals twice the radius. The circumference is the distance around the circle. This diagram illustrates the 3 fundamental parts of a circle: the radius, diameter, and circumference. The radius is the distance from the center to any point on the circle, while the diameter is twice the radius, stretching from one side of the circle to the other through the center. The circumference is the total distance around the circle and is calculated using the formula C equals pi times d, or C equals 2 pi r. These relationships are essential in aircraft maintenance when dealing with circular components like ducts, wheels, and fastener layouts. Pi, approximately 3.1415, is a constant ratio of the circle's circumference to its diameter. To calculate the area of a circle, use the formula area equals pi times radius squared. Unit conversion is crucial for accurate measurement. To convert feet to inches, multiply by 12. To convert inches to feet, divide by 12. For square and cubic units, use powers of 12 or 144. Always pay attention to the type of units: linear, square, or cubic. Solids are 3-dimensional objects like cubes, cylinders, pyramids, cones, and spheres. Their volume is always measured in cubic units, such as cubic inches or cubic feet. This figure represents a rectangular solid, also known as a cuboid, which has 3 measurable dimensions: length L, width W, and height H. To calculate its volume, you multiply these dimensions using the formula volume equals L times W times H. This calculation is crucial in aviation maintenance for determining material requirements, cargo space, and component packaging. Accurate volume measurements help ensure proper load distribution and efficient use of aircraft space. To find the volume of a rectangular solid, multiply length by width by height. The formula is volume equals L times W times H. A cube is a solid with 6 equal square faces. Its volume is calculated by cubing the side length. That is, side times side times side. This figure represents a cube, a special type of solid where all sides are equal in length, denoted here by the variable s. To find the volume of a cube, use the formula volume equals s cubed, or s times s times s. Since all edges are the same, calculating both surface area and volume becomes straightforward. Cubes are frequently encountered in storage, packaging, and component design in aviation maintenance. A cylinder has two circular ends and a set height. Its volume is calculated using the formula volume equals pi times radius squared times height. This diagram illustrates a right circular cylinder, defined by its radius tree and height h. To calculate its volume, use the formula V equals pi times r squared times h, which multiplies the area of the circular base by the height. Cylindrical shapes are commonly found in aircraft components, such as hydraulic reservoirs, fuel tanks, and filter housings. Accurate volume calculations help ensure proper capacity and weight distribution during aircraft design and maintenance. This is readily applicable to the cylinder of a reciprocating engine. A sphere is a perfectly round three-dimensional object. Its volume is found using the formula 1/6 pi times diameter cubed. As mentioned, the volume of a sphere can be calculated using the formula volume equals 1/6 times pi times diameter cubed, or expressed algebraically as pi divided by 6 times d cubed. This formula is especially useful when the diameter is known, eliminating the need to first find the radius. Understanding this relationship is critical in applications involving spherical components, such as pressure vessels, bearings, or fluid volume estimation in aircraft systems. Accurate volume determination ensures proper system design and load management. Trigonometry studies the relationships between the angles and sides of triangles, especially right triangles. It's widely used in construction, sheet metal layout, navigation, and surveying. In trigonometry, we label the triangle sides as base, B, the horizontal side, altitude, A, the vertical side, hypotenuse, C, the longest side. We also use angle labels A, B, and C, with angle C always being the right angle. To determine an unknown angle, we apply trigonometric functions, sine, cosine, and tangent, depending on which sides of the triangle are known. These formulas are only used when we don't already know two of the triangle's angles. Sine of an angle is the ratio of the opposite side to the hypotenuse. Sine A equals A divided by C, or SOH, in the SOHCAH-TOA memory aid. Cosine of an angle is the ratio of the adjacent side to the hypotenuse. Cosine A equals B divided by C, CAH, in SOHCAH-TOA. Tangent is the ratio of the opposite side to the adjacent side. Tangent A equals A divided by B TOA in the SOHCAH-TOA mnemonic. Each trigonometric function gives a ratio. Use a trig chart or calculator to determine the corresponding angle from the ratio. This theorem is essential for solving right triangles. To find the hypotenuse, a squared plus b squared equals c squared. To find one of the legs, subtract the square of the known leg from the square of the hypotenuse. Checking for a square corner, 3-4-5. Rule. To verify a 90-degree angle in the field, measure 3 units along one side and 4 along the other. If the diagonal between those points measures exactly 5 units, the angle is square. Graphs and charts provide visual representations of data, helping us quickly understand trends and relationships. In aviation and engineering, reading charts accurately is a vital skill. Common types include pie charts for percentages, bar graphs, line graphs, pictographs, nomographs, which are graphical calculators used for technical functions. This slide presents 5 common types of graphs used to visualize data: the bar graph, pictograph, broken line graph, continuous curved line graph, and pie chart. Each serves a unique purpose. Bar graphs compare quantities, pictographs use symbols for visual counts, line graphs show trends over time, curved graphs represent continuous change, and pie charts display proportions as parts of a whole. Choosing the right graph is essential for interpreting technical data in maintenance reports, system diagnostics, and performance tracking. This graph illustrates how engine power output decreases with altitude. As altitude increases, shown along the horizontal axis, the available engine power, expressed as a percentage of sea level power on the vertical axis, steadily declines. This reduction is due to decreasing air density at higher altitudes, which limits oxygen availability for combustion. Understanding this performance drop is essential for flight planning, engine tuning, and maintaining safe operational margins in aircraft maintenance and operation. This electric wire chart is a perfect example of how graphs are used in aviation to support engineering decisions. It shows the relationship between wire size, length, current in amperes, and acceptable voltage drop across different operating conditions. By using curves for continuous and intermittent ratings, technicians can select the correct wire gauge for a given electrical load and installation environment. Such graphs are vital for ensuring safe, efficient, and regulation-compliant wiring in aircraft systems. Let's now focus on measurement systems, starting with a metric system. The metric system is based on powers of 10. 10 millimeters equals 1 centimeter. 100 centimeters equals 1 meter. 1,000 meters equals 1 kilometer. It's consistent and easier to convert compared to the English system. The English system uses non-decimal units. 1 foot equals 12 inches. 1 yard equals 3 feet. 1 mile equals 1,760 yards. Because of its complexity, conversion tables are often required. Conversions between metric and English systems require specific ratios. For example, 1 inch equals 2.54 centimeters. Always consult a conversion chart when switching between systems. A function of numbers chart shows key relationships and calculations based on whole numbers, including their squares, cubes, square roots, cube roots, circumference, and area when used as diameters in circles. Congratulations on completing the General Mathematics module. The concepts you've covered, ranging from basic arithmetic and geometry to graphs and applied formulas, are the foundation for sound technical reasoning in aviation maintenance. Whether you're calculating structural loads, interpreting wire charts, or solving dimensional problems, these mathematical skills will serve as essential tools throughout your aviation career. Keep practicing, stay curious, and remember, precision in math leads to precision in maintenance. We look forward to seeing you in the next module.